then the vector diagram is given. I can see two vectors. The first one is the velocity of the boat, and the second one is the velocity of the water, which I assume is working against the boat. On figure 1.1, draw a vector triangle or a scale diagram to show the resultant velocity of the boat. So the the boat is actually moving something towards northeast, and the water velocity is towards west. This water, the velocity of this water, would try to bend the boat away from east. So the resultant velocity would be something in this direction. But we have to draw the vector triangle. So what I'm going to do is I'm going to draw the vector over here. The velocity vector, I consider the velocity vector as the second vector. So this is my second vector from here to here. And then in the next step, I pick up the second vector and I place it at the end of the first one. Then I know all of a sudden that this angle would also be 60. This one over here would be 60 degrees. How do we know? Alternate angle. Whenever they form AZ, something like this, and these two angles are always equal. Now, in order to draw the resultant vector, I need to join the start point to the end point. So something like this, and from start towards the end point. This is the resultant vector. You can label it as R if you want. Now the magnitude of this one was 3.0 meter per second. This one is 1.8 meter per second. And the first question does not demand the magnitude of the resultant vector. We had to draw it on the vector diagram. So 2 marks for us from this topic, from this part. Determine the magnitude of the resultant velocity of the boat. You need to find the value of this side. So you're provided with a triangle. One of these two sides are given and the angle between two sides are also given. What law can be used?
Cosine rule.
Exactly, the cosine rule, which is c square means the missing side, the side opposite to the given angle, a square plus b square minus 2ab cos of c. So just insert all the values here and take square root of it, and then let me know what do we get. The calculations is 2.6. You see, the resultant velocity of the boat is decreased. And could you state the reason for it?
Is moving away from the boat velocity.
Yes. Basically, the actual velocity of the water of the boat would have been 3.0 meter per second. But the problem is the water is working against us. So that water, the boat is traveling in the direction of the water. It has to do some extra work to get rid of that velocity of water. And that's why the resultant velocity has been decreased, which in this case is 2.6. And let me give you another example. Let's remove the water velocity from this side. Let's say the water velocity was towards right side. So this is the boat velocity and the water velocity is also towards the right side. In that case, the water velocity would actually assist the boat and the resultant velocity of boat would have been more than 3, because now it's going with the water, not against the water. It's now going in the direction of the water current. Then I can see the aircraft velocity in still air 95, and the wind velocity is 28. Okay, and then we need to draw an arrow labeled R in the direction of the resultant velocity of the aircraft, and then we need to find the magnitude of that resultant velocity. Now for this one, if I am to draw the vector triangle, I'm going to consider this vector as the first one, and eventually I'll call this vector as the second one. Now the vector triangle method says I have to pick up the second vector and place it all the way at the end of the first one. So this is how many, like, centimeters. We're not going with the scale drawing, but this one is from here till here. Okay. So I place the second vector at the end of the first one. Now what's the final step? The final step is we need to join the start point to the end point, and that's it. Start point, this was the start point, joins with the end point. So this is the resultant velocity of the aircraft. So just by looking at the vector triangle, what do you make of the magnitude of the resultant vector? Is it greater than the aircraft velocity? Is it greater than 95 or less than 95? If you compare the lengths.
Greater than 95.
Greater than 95. Now what could be the reason? I mean, in the very last question, the aircraft was replaced by boat and the wind was replaced by water, the velocity of the water. But in that question, the resultant velocity of the boat was actually lower than the velocity of the boat. But in this case, it appears that the resultant velocity of the aircraft is greater than the actual velocity of the aircraft. What could be the reason? How is this case different from the previous one? Yes, exactly. That is the reason. In this case, the wind is actually assisting the motion of the aircraft. You see, this is the vector, wind vector, this one. Or if you don't want to take a look at this one, I can say, let's go with, this is the wind vector. This angle is also 65 degrees. See, vertical angle, vertically opposite angles. So you see, this is the vector wind, the red one. This vector has two components. I can make two perpendicular components of this red vector. What are those two components? Let me show over here. Those two components of this vector would be like this. Okay, I'll just show over here the two components of wind. One component would be over here, the other component would be over here. So you see, one of the component, this component, is not going to affect the um, directly affect the aircraft velocity, but the other component, the one to the left side, is actually in the same direction as the velocity of the aircraft. And hence the resultant velocity increases. So this is for the vector triangle. Now if we need to find the magnitude of the resultant velocity, you see this is 95, this side is 95, this side is 28, the red one. The angle on the outside is 65, but we need the angle inside the triangle. So how much is that one?
115.
180 minus 65, which is right 115. So we are provided with two sides, and we are provided with the angle between two sides. We need to find the side opposite to the angle. What do we use? What mathematical tool do we use? Law of cosine once again, right? So can you apply law of cosine and give me the answer for this one? Okay, 109. In 2SF you can write it as 110 meter per second.